Hello again. Let's look at another example. The fifth root of 5, the cube root of 5, the cube root of 5 times the square root of x, all raised to the third power. Well, by fragmentation, that's just the cube root of 5 cubed times, and I need to put, that's sloppy, I need to put a times sign there. It was correct, but it was sloppy without the times. Times the square root of x cubed, but remember, the square root of x quantity cubed is the square root of quantity x cubed. So I just went ahead and cut the chase and wrote it like this. You know what? I kind of wish I wouldn't have, because really that's correct, but let me write it like this instead. That's more elucidating. So there we go. So that's the cube root of 5 cubed times the square root of x quantity cubed. That's just, but the cube root of 5 cubed, by the definition, is 5. The cube root and cube undo each other. The sixth root, like for example, the square root and the square undo each other. The fourth power and the fourth root undo each other, so on. So the cube root and the cube undo each other. Assuming all numbers, the interior like 5 is positive, which it is. And then so this is just 5 right here. And because the cube root here and the cube here undo each other. And then the square root of x to the third power, well, that's rad x, radical x, radical x. Now, the two radical x's combine to get x. So there's that. So we have 5x times radical x. So there's that. And that'll be all for that example. Now, again, if I'd have done the cube root of x here, it's actually much prettier. That's just, since these are both cube roots, we couldn't do this earlier. They weren't the same radical. But these are the same radical, so we can bring the x in with the 5. That's just the cube root of 5x cubed by consolidation. But the cube and cube root kill each other, and we're just left with 5x there. Notice that was actually much prettier than the last example. Now, if we do the fourth power, well, notice that we can still consolidate this. But it would be great if we could break the... Notice that this can be thought of as the cube root of 5x to the fourth power. But since I got a cube root here, it would be nice if this was a 3 instead of a 4. Now, I can't just wish that 4 away. But what I can do is, remember, something raised to the fourth power is that something cubed times that something to the 1 power, which is just itself. Let me insert the middle step. So what's going on here is... we've got, let me insert the cube root here. So we got the cube root of 5x and then entity, everything's going wrong. Sorry guys. Entity raised to the power of 4. So you can, the second step, I shouldn't have skipped it. Here it is. So that's the cube root of x to the fourth power, but thingamabob to the fourth power is thingamabob cubed times thingamabob to the 1 power. And thingamabob being the cube root of 5x. Okay, so something to the third power times something to the understood 1 power is just something to the fourth power here. But now the cube root and cube kill each other, and you're just left with 5x. So we got, and that's sloppy. Let me bring that down. So our final answer is just the 5x that came out, because the cube root cubed is just the 5x itself. This is 5x itself right here. So we get 5x itself times the cube root of 5x. Now that won't change. This guy stays, this is just copy and paste. So there's that. And likewise, the fifth power, notice that we'd like that 5 to be a 3, so we chunk it up into, we go ahead and bring the 5x together. And again, that middle step, it's similar, it's fairly similar to this one, except we got a 5 power instead of a 4 power. So let me just insert that here. And so we got the cube root of stuff to the fifth power. That's the cube root of stuff cubed times the cube root of stuff squared. You break up this 5 into 3 plus 2. The reason I want this 3 here, guys, is because it's going to kill this cube root here. It's the same reason I wanted it up here. Okay, this cube kills this cube root. Now the cube root and the cube kill each other, and you're just left with 5x times. Now you're out. Jason, you see this square here? What happens is it comes inside, you square 5x and you get 25x squared. There's a step that I skipped. I'll insert, I need to insert it. So obviously the cube root of a cube is just the thing itself, 5x. So that was a non-issue. And then times, now here's what's going on. The cube root of 5x parentheses squared, that's the cube root of, and then you bring that 2 inside here and you square 5x. But you need to square 5 and x, so what you're doing is you're parentheses 5x, you're squaring the whole thing 5x, so you need these parentheses here. They are important. So we're squaring the whole thing 5x right here. Now if you do 5x squared, parentheses squared, that's 5x times 5x, that's 25x squared here. If that looked a little mysterious, I hope that cleared up the mystery. Okay, so let's recap. The cube root of 5 times the cube root of x, that's just the cube root of 5x. Now we're 5 powering, but the cube root would like to have a cube power. So I need to break 5 up into 3 plus 2 in order to get the 3. So this cube kills a cube root. That was the whole motive. And we get 5x, the motive, times the cube root of 5x squared, which can't come out. And by the bring-in law, I can bring the 2 in here and square the 5x. So I get 25x squared right there. 5x times 5x. So there's that. Let's look at another one. Now this one is actually much nicer because 6 is a multiple of 3. We don't, it would be, for this time, actually, we bring together, so we have the cube root of 5x, and we have it to the 6th power. But now it would be silly to do it the other way. Notice that's just parentheses 5x to the 6/3 power. The 6 over the 3, that's just in fraction exponent form. But 6/3 is 2. So that's 5x parentheses to the 2 power squared. But that's just 5x times 5x, which is 25x squared. Notice that turned out much prettier in a way than, actually, totally much prettier than this one, if you ask me. So that's the end of that one. Now let's just go down here. Let me do a recap. The square root of x times the square root of x times the square root of x. These two square roots of x just make x. We're assuming all variables positive. So that's just x radical x, okay? So there's that. All variables positive again. Radical 3x times radical 7x times radical 5x. And by radical, I mean square root. You bring these in together. 3x times 7x times 5x is 105. X times x is x cubed. But remember, what happens, guys, is now 105, there's nothing. 105 is 5 times 3 times 7. Notice that nobody is a perfect square. The biggest perfect square that will cut into 105 is unfortunately 1. And 1 doesn't do anything for me. So 105 is stuck. As big as he is, he's stuck. 5, it's equal to 5 times 3 times 7. Nobody appears twice, so there are no perfect squares. Now x cubed, we can do a little. Notice that x cubed is x squared times x. And x squared, let me insert that step. Oops, if it bothers you. Some of you may already see it, but if you don't, here's what the 105 can't come out because there's no perfect square other than 1 that will go into it. But notice you turn x cubed into x squared times x, but this x squared, guys, comes out as x. We're assuming all variables are positive. So you remember, you take this 2 and divide it by this understood 2 in the index. Okay, and you get a 1, so x to the 1 comes out, but that's just x itself. And now this 105 here and this other x to the 1 right here, it stays in, the original x to the 1. So it just stays in. And I'll stop the video here and we'll move on to the next video. Thank you.